Yeah, good afternoon. I'm glad you're here, and I hope you have a good time here in VMWareExplore. Here today, we're here to talk about a game changer. And when we talk about game changers here in Barcelona, they will very know how to do that. They have actually crafted one of the most game-changing events, giving to the world a new term, La Remontada. And today we will see how our game changer is and why your data deserves it.
Right, a short disclaimer. So you see features in this presentation that are still in development. So they are subject to change, and VMware doesn't have any commitments to deliver them in any of the future releases. Okay.
Yeah. Before we zoom into VMware Cloud Storage, let's take a look on the solution which VMware provides in order to support the increasing demand of storage. It's a service which is jointly engineered between AWS and VMware, and it aims to put the enterprise-class software-defined data center into the cloud, together with well-known vSphere, vSAN, NSX, put it into dedicated bare metal in the form of EC2 instances. So the service is delivered and operated by VMware, which means VMware are producing the upgrades and the patches, and also VMware is the point of contact for the users which are using the service. And VMware Cloud and AWS exposes directly more than 200 native AWS services. The full operational consistency with the on-premise software-defined data center makes it easy to move workloads from on-prem to the cloud. The APIs which could be used for that are the same. vCenter and vSphere APIs are standard, so that no refactoring or additional effort is needed to adopt the existing automation for the move to the cloud. Yeah. We benefit from the flexibility which cloud gives in terms of cost and usage, and the service is provided in on-demand and standard subscription models. So stepping on this foundation, let's see what are the storage options we have.
Yep, next slide. Yeah, so the main storage offerings that we currently have in VMCFS are vSAN and the new one, VMware Cloud Flex Storage. Now, I'm going to refer to VMware Cloud Flex Storage as a VMCFS because the actual name is too long, but VMCFS means VMware Cloud Flex Storage. Let's see the vSAN offering first. Now, vSAN is a great durable storage offering. Its HSI hosts come with high available storage, and it's actually great for running any kind of workloads on it. And especially workloads that demand high OPS, low throw input, and low latency. Now, the payment model in vSAN is you pay per host. That means that if you want to scale storage, you need to add one new host to it. And this will lead to scaling compute as well. And that's not ideal for some customers because they might not need the new compute. That's why we introduced VMware Cloud Flex Storage. It's a fully managed service by us. It's really easy to operate, really easy to use. You don't need to configure networking. You don't need to configure almost nothing. And really the cool part is that you pay per gigabyte used. So you can scale storage independently of compute. Now, I will hand over to Stefan to talk about a little bit more about this product.
When talking about cloud storage, people start asking a question about object store. These questions are valid because object store has some neat characteristics. Yeah, S3 buckets are cost effective. They scale really smooth and easy, and the durability is in the nature of this service. We get a lot of nines without doing anything, just using what we have out of the box. And what we have as feedback from our customers using VMware Cloud on AWS is that they have expectations for multidimensional resource scalability. This means that they see the scale of compute, storage, and performance in terms of IOPS separately. The reason for this is that not all workloads scale uniformly. And if we talk about simplicity, to explain simplicity with words already create complexity. That's why we will show in our demo, we will demonstrate this simplicity in the demo in a while. So I'm giving back the floor to Evtim to talk about the architecture.
Yeah. So I want to present you like a high overview of the architecture of this offering, and I would love to go deep into clamps and what we do under the hood, but we need a day or so to do that. So we're going to do a high-level overview. Now, this storage is built on top of a file system that's production hardened over many years. And actually, a fun note that this file system is backing up our disaster recovery solution. We call it the scale-out cloud file system. And this scale-out cloud file system uses the TTR architecture, or it's safe to say we have two layers. One layer is the data management layer, and the second layer is the performance layer. As you can see, here we have the elastic capacity, which is the data management layer, and here we have the cache for higher performance, which is basically the performance layer, right? So two layers. Layer one, the data management layer, is all about scaling your data at the lowest cost. That being said, we use as a foundation in layer one, S3. And we use S3 because S3 is cost efficient, it's durable, it's cross-region, and many, many more things. On top of that, we wanted to optimize even further the performance of this layer. That's why we decided, hey, S3 works really good with sequential locks. And we decided to implement on top of S3 the so-called log structured file system. And there's a great paper about what this actually does, but in a very short summary, essentially the log structured file system converts your small write IOs into big sequential logs. And as I mentioned, S3 works really great with them. The log structured file system, as you can see here, is implemented via two backend nodes. And by backend nodes, we essentially mean EC2 hosts that work in a high available pair. OK. The next layer is the cache node, or the performance layer. Here we have cache for higher performance in this chart. This layer is all about performance. We have one cache node, which is, again, essentially one EC2 host, which is basically bringing us the caching functionality, and it stores the data in memory. And by doing so, we reduce the read latency to around 1-2 milliseconds, or something like that. And this is with our current architecture. If this cache node fails, we will fall back to the backend node, and we can read the data from layer one. Yes, of course, this will bring the read latency up to, it can bring it up to 10 seconds or something like so, but we have new features that will handle this in the later slide. So, yeah, and with this architecture, basically you can scale performance and storage independently. This is, I think, the best things about it. Next slide, please. Right, in this slide, we've prepared some examples, and we try to give you an idea on how we potentially use this product, which type of workloads, and I guess some idea on, general idea on how to use it. In the first chart, we can see that for mission-critical, high-performance, and low-latency workloads, in the current version, we recommend vSAN, as it's a really good storage. It's a really good storage offering for that. VMCFS is great for backups, file servers, and log files, and many, many more applications. And actually, in the second chart, we've tried to summarize those applications, and these applications are actually applications that we actually tested on, and we know that these applications work really great on VMCFS. And we did some kind of a category, so VMCFS works great for file servers, multimedia archives, log files, analytics, backups, and database archives. And actually, this is just some of the examples that VMCFS for VMCFS. Okay, next slide, please. Now we're going to talk about availability. As you can see, we highlighted the regions that VMCFS is supported, but it's safe to say that VMCFS works on all major regions that support VMC and VCDR. Now, I'm going to hand off to Stefan to talk about our vision of this product.
Yeah. We see VMware Cloud Flex Storage as enterprise-class storage for data management for the multi-cloud. Even though in this presentation we focused a lot on Flex Storage on AWS, we do envision the solution enabled on other cloud providers too. And we'll continue leveraging the cloud abstractions in order to provide the lowest cost possible per gigabyte. And in terms of data management, we're planning features around snapshots. These are the same snapshots which are driving our data protection offerings like ransomware recovery and VMware Cloud Disaster Recovery. So features like doing snapshot, cloning it, restoring it on some sandbox are essentially giving data management capabilities. Evtim mentioned that vSAN is the preferred option for workloads which require consistent low latency. However, we see at some point of time VMCFS as a suitable solution for such workloads too. We have in our roadmap items in direction of availability and performance. And that's how we see in the future VMCFS. Here I can show you some recent developments which are putting us towards our vision. The main developments are in two areas: higher scale and strengthened resiliency. Enterprise environments can scale to petabytes, and currently VMCFS supports like one data store with 400 gigabytes. That's good enough for most environments, but we're willing to push these limits, to extend these limits, and now give the possibility to use up to 4 data stores, and each of these data store can have 800 TB bytes. In terms of resiliency, we want to be sure that the solution performs constant latency, even regardless of the interruption in the infrastructure, regardless of problems and failures on this infrastructure. And Evtim will tell you a bit more about these initiatives, a bit more in detail.
Yeah, thank you. So let's start with higher scale. Now, with the current version that we have, you can do up to 400 terabytes per file system. And I just want to mention here that this is based on 2-to-1 dedupe ratio, and you can get slightly different results based on different type of workloads. From the next release, you will be able to go up to 800 terabytes, which is almost double the capacity. Now, with the current version, you can attach only one file system per SDDC. And we heard from our clients that one file system is just not enough per SDDC. That's why, in the next release, we are going to allow up to 4 data stores per SDDC. And if I can sum up everything, so you can go up to 800 terabytes, and you can have up to 4 data stores per SDDC. That basically means that you can have up to around 3.2 petabytes of data in one SDDC. And again, this is based on 2-to-1 dedupe ratio. Yeah, next slide, please. Now, let's talk about resiliency and what we did. As I mentioned in my previous slides with the architecture overview, we have one node in the performance layer. And if this node goes down, and I just want to mention here that this is a very unlikely scenario for AWS because we are talking about EC2 hosts. But even if it goes down, we need to fall back to layer 1. We need to read the data from S3, which will boost the read latency. Now, I was thinking what we can do to improve that. Hence, we added a second cache node. And the result is that we now have, or with the next version, we will have 2 cache nodes on this layer that work in a high availability pair. If one cache node fails, and again, highly unlikely scenario for AWS, but if it fails, the other cache node can take over without disruption. I think the estimation is less than 60 seconds or so. Right. So, having additional to that, we added 2 cache sizes. So, in the next version, you will have 30 terabytes and 60 terabytes option. And again, we can switch without disruption. It's a matter of configuration, and this brings, I think, additional flexibility. Now, with these 2 features, the resiliency and capacity enhancements, it's safe to say that from the next release, we will recommend this product, VMCFS, for mission-critical applications. OK, next slide, please. Right. Now, in this slide, we prepared some metrics of the performance expectations from what we will get from these 2 features. And I will not go over each metric here. We will share the presentation so you can go over it. But I just want to say here that we will expect improvements in read latency and write latency. Now, we talked a lot about the architecture. We talked about our vision and what we want to do in the future with VMCFS. Now, let's see everything in action. Now, we prepared the demo. And basically, the idea here is to, yeah, we can start it. So the idea here is that we are going to create 4 data stores and attach them to one SDDC. And essentially, we are going to scale our storage up to petabytes of data. The whole idea of this demo is to show how easy it is to work with this product, how easy it is to scale the data. Again, no configuration, no networking, everything is managed by us. So as you can see, we're creating the name. We need to select the SDDC, then create data store. Yeah, and then the creation will start. Now, until we're creating our 4 data stores, I just want to mention something that I didn't mention in the slides, but I think it's worth telling about. We did some improvements on the UX, and we implemented the concurrency model, meaning that you can provision, mount, unmount, delete data stores, and by data stores I mean file systems, at the same time. So you don't need to wait one operation to finish. You don't need to wait one data store to be created so you can create. You can do everything at the same time. Right, so we've created our data stores, and yeah, if you go to VMC, we can see that on this cluster, yes, data stores are here and ready to use. I mean, that's it. This is how simple it is to provision data stores, provision file system, and scale your storage with just a couple of clicks. Stefan?
And maybe a few words about this limitation.
Yeah, we're showing here that we've reached the limit of 4 data stores per SDC, and you cannot no longer add data stores.
Yeah, cool. That was nice. With a few clicks, we provisioned like a petabyte scale.
Up to petabyte scale of data in one SDC.
Yeah. So that was what we have prepared for you today. I hope it was interesting for you. And if you have questions, please send a message to this email you see on the screen. Yeah.
Yeah, thank you. We'll be here if anybody has questions.